Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Syahada binti Musa. My metric number is AE180105. We will be presenting about our group assignment project, which is the title is Home Water Pump Speed Controller Using DC Motor. We are from section 1 and our group member consists of 3 members, which is Muhammad Badrul Amin bin Abdul Muttalib, Diki Vikananda Nafis, and also including myself, Nurul Syuhada binti Musa. We will proceed to the project background. The project background in this group assignment is system must model using the requirement that have been mentioned in the instruction, which is the system that we develop must consist of DC motor, a speed loop controller, either proportional integral PI or PID, proportional integral derivative, or both. And also, microcontroller algorithm should be included. Okay, in this project, we just focusing on choosing PI, proportional integral, and our speed controller in this as our speed controller in this system. A step-down buck converter was also added to the system. As a result, the system output voltage will be lower than the system input voltage. MATLAB Simulink tools were used to find and design all those components that are required in the instruction for this project. This is our block diagram for the system, which is consists of PI controller, buck converter, and also DC motor from the speed reference. And then we go to the PI, which is PI is function as to control and do correction to make sure the output follows the all command. Okay, the combination of PI in this circuit will help to control the changes that may happen in the system automatically. It simply detects a required input that must be sent via a buck converter for a step down to a low DC voltage before driving the motor and then to the load. When the motor speed is being monitored, it will deliver back to the PI controller if the motor speed exceeds the required or reference speeds. That's all from me for the block diagram. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Diki Vikananda Nafis and my metric is GE 2082. Today I will present about the equipment and the simulation. The first is the duty cycle. The duty cycle use the buck converter. This buck converter and then use the motor that RPM is 1750 with the 5 HP. And there is LPI here. You can see the PI that we can control the motor speed. So when the PI goes up, then the graph goes up too. When the P is down, the graph is down too. When we use the integral, it lessen the overshoot of the graph. And then there is a formula. About the motor, we use that can make 1750 RPM with 5 HP. With this simulation, we hope to make one water pump that usable in the young usage that we can use to full the swimming pool through. Peace and thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum, my name is Muhammad Badrul Amin bin Abdul Talib. Now I want to present about the simulation of our design. This is our circuit, which is to create the DC motor that we have varying speed. So our objective is to create the varying speed of DC motor, and we use the PI controller and the buck converter. This is a buck converter. We use the MOSFET as a switch, diode, and inductor and capacitor. This is our motor that we use, which is the specification is 5 HP, 240 volt, 1750 RPM, and free voltage is 300. We set the free voltage is 300 here, and this is to check the voltage output. And the motor will produce the speed in radians per second. Then we will convert into the RPM. This is a feedback to the PI. So we set the voltage input is 300 volt, and this PWM is with switching frequency is 5000 Hz. This block diagram is transfer function that convert the speed reference into the duty cycle, and because the PWM need the pulse in duty cycle to generate pulse into the switch. So the inductor we set 3.86 times 10 power of negative 4, which is 0.386 millihenry. And this is the capacitor we set 5.18 times 10 power of negative 4, which is 0.1518 millifarad. So this is the free voltage 300. The load torque which is 20.25 newton meter. We have set this is fixed. Then this torque we use from the formula. Then the motor we will produce the speed. So we will run this simulation without using the PI. So we will see the output without using the speed controller PI, which is PI. So let's run. You can see the voltage output is 117.3, and the speed produced is 620.3 RPM. So the speed reference is 1750 RPM. So this is not same. This is because we not use the PI controller. So we see the graph first without PI controller. This is the graph for not using PI controller. Let's put the PI controller here and run again. Okay, what we can see is the voltage output is 240 volt, and the duty cycle is 0.8, which is 0.79, which is 0.8. Then what we can see and conclude, the voltage input Vin is 300 and the duty cycle is 0.8. The voltage output is equal to Vin times duty cycle, which is from buck converter formula, and we get 240 based on calculation. So we get the voltage for the simulation is correct because same as the calculation. Then the speed from the motor, which is 1750, so same as the speed reference after put the PI controller, which is we set 120. So we see the graph. This is the graph. This is the speed reference, blue line, and the yellow is from the motor. So there's no overshoot, which is this is good. So we try with the other value, is 1000, 1200, and let's see what the motor speed. So what we can see, the duty cycle is 0.6 and the voltage output is 179.2. So the voltage output and the duty cycle is correct. Then the motor speed is 1200, same as the speed reference, so it's good. Then we see the graph, and there's no overshoot, so which means the setting for PI controller is good. Let's see if the PI controller set like this. Okay, we can see the result. The voltage output is changed into 183.3 volt, and the value of the motor speed is same as the speed difference, but we can see the graph. There are overshoot here. We can see here the 1271. So this is not good. So we need to change the PI controller setting to 6. That's all from me for the simulation of this circuit.